Okay, so we have continuous function. So actually, we have already described this last meeting by the time we have discussed yung sa limits. Okay, so we have continuous functions. Okay, so previously we saw a few nice functions whose limits as x approaches a simply involve substituting a into the function. So that's the algebraic way of finding the limit. Kumbaga, you just simply substitute the given value of a doon sa function na given. For you to have the limit or the limit of the function as x approaches a is equal to f of a. Functions whose limits have this substitution property are called continuous functions. So kapag may ganito, they are called as continuous functions. And they have a number of other useful properties and are very common in applications. So we will examine what it means graphically for a function to be continuous or not continuous. So some properties of continuous functions will be given, and we will look at a few applications of these properties, including a way to solve horrible equations such as sine of x, 2x plus 1 over x minus 2. Yan. So we have the definition and meaning of continuous. So a function f is continuous at x equals to a if and only if the limit of f of x as x approaches a is equal to f of a. So ito yung kanina dito. Okay? So here, the graph in figure 1 illustrates some of the different ways a function can behave at and near a point. Ito dito. Okay? So may mga ganitong functions na ganito yung graph nila. And table 1 naman contains some numerical information about the function and its behavior. So dito siya. Okay? Based on the information in the table, we can conclude that f is continuous at 1 since the limit of the function as x approaches 1 is equal to 2 is equal to f of 1. So dito sa table natin, equal yung value ni f of a at saka ni limit of the function as x approaches a. So equal yan. Okay, so we can say that the function is continuous at 1. We can also conclude from the information in the table that f is not continuous at 2 or 3 or 4. So hindi siya continuous dito at a equals to 2, 3 or 4. Kasi nga they are not equal. Itong f of a at saka ang limit ni function as x approaches a yan, hindi complete. Hindi siya equal. So they are not, or the function is discontinuous at a equals to 2, 3 or 4. Now let's have the graphic meaning of the continuity. So when x is close to 1, the values of the function are close to the value of f of 1. So yan. Okay, so if x daw is closer to 1, then the value of x is also closer to f of 1 or the 2. Yan. Here, we can also say that we can also see that walang holes if x is equal to 1. Walang holes, so solid that yan and then connected. So the graph of f is connected at x equals to 1 and can be drawn without lifting your pencil. Okay, so that is one way of knowing that a function is continuous if you can trace the graph or the curve without lifting your pen or pencil. Kumbaga, continuous siya. Okay, yan. No breaks, no holes. Okay, here at x equals to 2 and x equals to 4, the graph of f has holes. Yan, x equals to 2 and x equals to 4. May mga holes dyan. Okay? And at x equals to 3, the graph has a break. Okay, dito may break siya. Yan. Kumbaga, hindi connected dito kasi may break dyan. And then, makikita mo din kasi nga hindi solid yung broken line dito. Yan. Okay, so hindi siya connected. So may break. So the function f is also continuous at 1.7. Bakit? So 1.7 ay nandito. Yan. Okay, assuming here. So it is still continuous since from here you can still trace the graph without lifting your pencil and then walang breaks, walang holes. And then, and at every point shown except at 2, 3, and 4. So dito continuous din siya. Dito continuous din siya. Yan, dyan. But not on 2 kasi kapag 2, no, may holes dyan. 3, may break, may holes. 4, may holes din. So kumbaga sa exact na values ng 2, 3, and 4, the function here is discontinuous. Dito lang siya continuous kay 1, less than 1 dito. Dito, less than 2, less than 3, less than 4. Yan. So a function is continuous at a point if the graph of the function is connected there. So a function is not continuous at a point if its graph has a hole or break at that point. So yun lang. Kapag may mga ganito, then we can say na the function is not continuous sa point na yan dito. Pero kung ganito, so continuous siya dito kay 1. Okay, sometimes the definition of continuous or the substitution condition for limits is easier to use if we break it into several smaller pieces and then check whether or not our function satisfies each piece. So actually, we have already discussed this one last meeting. So itong 3 conditions. So for us to say that the function is continuous, we need to satisfy these 3 conditions here. So f is continuous at a if and only if the limit of the function as x approaches a is equal to f of a. If and only if, number 1, f is defined at a. So if we say defined, hindi siya undefined, hindi din siya indeterminate, hindi rin siya imaginary. Number 2, the limit of the function as x approaches a exists. So if we say nag-exist ang limit, same din dito kay number 1, hindi siya undefined, hindi siya indeterminate, hindi din siya imaginary number. So here, ang ibig sabihin din nito sa number 2 is the left limit and the right limit exist and are equal. So if we say left limit, that's from the left of a, so kumbaga less than a, and then right limits, that's from the right of a or more than a. And the last condition is the value of f at a equals the value of the limit as x approaches a. Kumbaga, itong si third condition is dapat daw kung ano yung value dito kay first condition o dito sa first, it should be equal dito sa second. So kumbaga, the limit of the function of x as x approaches a is equal to f of a. So if the function satisfy conditions 1, 2, and 3, then f is continuous at a. So kapag nasatisfy natin itong tatlong conditions na nandito, we can say that the function is continuous. Pero kung hindi naman, or kumbaga may hindi na-satisfy na kahit isang condition dito, then we can say that the function is not continuous at a. Okay. So here, for the function in figure 1 at a equals to 1, all 3 conditions are satisfied. Kumbaga, defined itong si f of a, yung limit of ni f of a naman, nag-exist, and then same yung f of a tsaka ni limit ni f of a or ni f of x as x approaches a. And then at a equals to 2, conditions 1 and 2 are satisfied but not 3 kasi nga hindi equal. So if f is not continuous sa 2. At a equals to 3 naman, condition 1 is satisfied but 2 is violated. Okay, balik tayo dito sa table. Okay, so violated yung dito kasi hindi siya nag-exist. So the second condition is violated. Hindi nag-exist ang kanyang limit. Okay, so if a equals to 4 naman, condition 1 is violated. Okay, condition 1 is violated since undefined yung f of a. So, kumbaga no need, kung nakita mo na agad na sa first condition pa lang hindi na satisfy, then you can say directly that the function is not continuous. Yan. So a function is continuous on an interval if it is continuous at every point in the interval. So a function f is continuous from the left at a if the limit of the function as x approaches from the left of a is equal to f of a, and is continuous from the right if the limit of the function as x approaches to a positive or from the left of a, from the right of a is equal to f of a. Okay, so example. Okay, kunwari dito, nakita natin. So, we have 3 lines of equations here. So, we already know how to use this. kumbaga, kailangan muna natin tignan yung nandito and then we can identify kung ano yung gagamitin natin sa first line ba, second line, or third line na equation. So here we have three conditions or three values of x or a. So first is 1. So we could answer these questions by examining the graph of the function, but let's try them without the graph. So at a equals to 1, ito. So kung 1 siya, dito siya belong sa first line. X is less than or equal to 1. So we will use this function, x plus 1. So 1 plus 1, that's 2. And the left and right limits are equal. So tignan natin yung left muna. From the left. So if we say from the left, less than 1. So kung less than 1 siya, dito pa rin siya belong. X is less than or equal to 1. So ito pa rin na equation ang gagamitin. 1 plus 1, that's 2. If we say from the right, that is more than 1. So kung more than 1, definitely hindi na natin magagamit ang first line. Dito na siya sa second line. X is greater than 1 but less than or equal to 2. So the value is 2. So yun na nga, they are equal from the left and from the right. So f is continuous at 1. Yan. How about for at a equals to 2? Okay, at a equals to 2, kung 2 siya, hindi na siya pasok dito sa first line. So gagamitin natin ay yung second line. Okay? So sa second line, we have x is greater than 1 but less than or equal to 2. So dito siya belong. We will use the second line which is 2. Ito. Let's have the left and right limit. So kung left limit is less than 2. So kung less than 2, okay, dito pa rin siya belong. X is greater than 1 but less than or equal to 2. So we have 2 for the left limit. Kung right, that is more than 2. So hindi na siya pasok dito sa second line. We will use the third line. X is greater than 2. So we will use this equation 1 over x minus 3. So we have 2 as our x. So 1 over 2 minus 3, that is negative 1. So 1 over negative 1, that is still negative 1. So as what you can see, hindi same yung left at saka right limits niya. So f fails condition number 2 and is not continuous at 2. Yan. F is continuous from the left at 2 but not from the right. Okay. Next, at a equals to 3. Okay, so kung 3, we have dito siya belong sa third line, x is greater than 2. So 1 over 3 minus 3. That's 1 over 0. Okay? So 1 over 0 is undefined. So f is not continuous at 3 because it fails condition number 1. So kitang-kita na dito lang talaga siya continuous at x or at a equals to 1. Okay. Next, where is f of x equals to 3x squared minus 2x continuous? So, kumbaga may mga questions din na pwede siyang maging ganito. Find the value of x wherein the function is discontinuous or kailan siya magiging hindi continuous. Okay, so the technique here is you need to find a number or you need to know if there is a number na makakapa-undefined sa equation na yan. So usually, magiging undefined yung equation if ever 0 yung kanilang denominator. Or magiging 0 both denominator and numerator. Yan, 0 over 0. O magiging imaginary, hindi pwede yan. Okay, so here, itong si 3x squared minus 2x is continuous at every point kasi wala kang makikitang number or value ni x wherein makakapa-undefined dito sa kanila. Okay, so we have the rule na by the substitution theorem for polynomials, every polynomial is continuous everywhere. So kumbaga, if ever polynomial yan, kumbaga, ano talaga siya, continuous siya always kahit na anong value ni x. Kasi wala naman siyang denominator, hindi siya magiging undefined. Next, where are g of x and h of x continuous. Okay, dito these are rational functions, no? So kapag rational functions na, ang gagawin lang is you need to find the value of x here na makakapag-0 dito sa denominator. So definitely, dito sa first kay g of x, ang makakapag-0 dito is kapag x is 3. Okay, so we have x plus 5 over 3 minus 3, that's undefined kasi magiging 0 yung denominator. So kumbaga, itong si g of x is continuous everywhere except where its denominator is 0. Or g is continuous everywhere except 3. Okay, kung 3 ang value ni x. Dito naman kay h of x, you need to find the values of x na makakapag-0 dito sa denominator. So since this is a binomial, we need to find the zeros or the roots of this binomial. So all we need to do is to factor this binomial. So factor lang yung binomials na yan. So ito yung factor ng binomial natin sa denominator. So we have x minus 1 times x minus 3. Now equate this to 0. So we have x minus 1 equals to 0. We have x equals to 1. Dito naman, we have x equals to 3. So kumbaga, itong si h of x, ito siya, is continuous everywhere except where x is equal to 3 and 1. Yan, 3 and 1. Kasi magiging 0 yung ating denominator. So this is the graph. So kung i-graph natin yan, magiging ganito yung kanyang forma. May hole. Yan. Okay, next is where is f of x equals to int x continuous? This is the greatest integer. So we have already encountered this kind of function previously. Okay, the graph of y equals to int x seems to be connected except at each integer. And at each integer, there is a jump. So ito yung graph ni int x. So nakikita natin may mga holes dyan and then may jump, no? Di connected, hindi siya mako-connect dyan. Okay, so if a is an integer, then the limit of int x from the left of a is equal to a minus 1 and the limit of the int x from the right of a is equal to a. So the limit of int x as x approaches a is undefined kasi nga hindi equal yung kanyang left at saka right limits, and int x is not continuous. So kita naman 'di ba? Kasi kanina nga kapag nasabi natin na kapag continuous ang function, then we can trace the graph without lifting our pen or pencil. Dito, hindi mo siya matitrace lahat kasi may mga jumps. So, kitang-kita na this is not continuous. But, here, dito naman sa mga numbers between -1 dito, for example, this is negative 0.5, here is 0.5, here is 1.5, 1.7, 1.8. Continuous siya kasi andyan siya. Oh. But di siya continuous sa mga exact number of integers like -1, 1, 2, 3, 4, and so on. Yan. Next here, we have a practice problem. So if you want to try, then you can try. And then check your answer mamaya kasi may ano naman sa baba, may answer key. Yan. Now, why do we care whether a function is continuous? Yeah, so there are several reasons for us to examine continuous functions and their properties. So most of the applications in engineering, the sciences, and business are continuous. And they're modeled by continuous functions or by pieces of continuous functions. So usually, yung mga nakikita natin or mga nangyayari sa paligid natin, they are modeled by continuous functions. So continuous functions have a number of useful properties which are not necessarily true if the function is not continuous. So if our result is true of all continuous functions and we have a continuous function, then the result is true for our function. So kumbaga, generalize yung concept ni continuity. Kumbaga, kung continuous itong function na ganito, it will apply to all this kind of function. So the same with kanina sa polynomial function. So kahit anong polynomial pa yan, They are all continuous. So this can save us from having to show one by one that each result is true for each particular function we use. So some of these properties are given in the rest of the section. So differential calculus has been called the study of continuous change. And many of the results of calculus are guaranteed to be true only for continuous functions. Yes. So if you look ahead into chapters 2 and 3, you will see that many of the theorems have the form. If f is continuous and then ganyan. So kumbaga sa calculus is, kumbaga yung mga theorems niya is may ganito talaga. If f is continuous and ganon, ganon. Yan. So, kumbaga, kaya tinawag siya na study of continuous change. So, it's all about continuous functions. Okay, next we have combinations of continuous functions. So, we have already studied also, we have reviewed this combination of functions. So, if f of x and g of x are continuous at a and k is any constant, then the elementary combinations of f and g, you have k that f of x plus g of x, f of x minus g of x, or f of x times g of x, and f of x over g of x, wherein g of a is not equal to 0, are continuous at a. So, nakita natin to sa mga properties ni limits last meeting. Okay? So, yan. Here we have composition of continuous functions. So if g is continuous at a and f is continuous at g of a, then the limit of the f of g of x as x approaches a is equal to f. Then have the limit of the g of x as x approaches a is equal to f of g of a. So the composition, or f of g of x is equal to f of g of x, is continuous at a. So kumbaga, yung combination ng functions and then the limit or the composition of the limits of the function is also continuous. So may here, so may mga konting description dyan, and then we have this theorem. So the next theorem presents an alternate version of the limit condition for continuity. And we will use this alternate version occasionally in the future. Ito, theorem. The limit of the function, or the f of x as x approaches a, is equal to f of a if and only if the limit of the function, or the f of a plus h as h approaches 0, is equal to f of a. Okay, so may proof ito dito. So you can read this proof. Yan. But we have this one. A function f is continuous at a if and only if yung limit ni function of a plus h as h approaches to 0 is equal to f of a. Kasi nga approaching to 0 itong si h. So same pa rin siya sa kung ano yung value ni a dito. So equal siya sa pag-substitute mo directly sa given value of a doon sa function. So which functions are continuous? So fortunately, the situations which we encounter most often in applications and the functions which model those situations are either continuous everywhere or continuous everywhere except at a few places. So any result which is true of all continuous functions will be true of most of the functions we commonly use. So same ito sa nangyari kanina na basta polynomial, always yan siya continuous. Pero kapag rational function, so hindi siya continuous if ever magiging 0 na yung kanyang denominator, or 0 both ang numerator and denominator. So we have this theorem. So the following functions are continuous everywhere at every value of x. So si polynomials, they are always continuous. Si sin x at saka cosine x din, always continuous, as well as the absolute value of x or any number. Yan. Okay, same with sin x. So ito yung graph ni sin x. So continuous yan. Walang holes, walang breaks. Okay. This is also the graph of the absolute of x. So wala ding breaks, walang holes. So continuous yan. So a continuous function can have corners but not holes or breaks. So ito may corners siya. Pero wala siyang hole, wala siyang break. Here. So we have this theorem na a rational function is continuous except where the denominator is 0. Yan. Itong na-solve natin kanina. Then tangent, cotangent, secant, and cosecant are continuous except where they are undefined. Yan. So, sine and cosine lang yung hindi, yung always continuous. The greatest integer function is equal, or this one, is continuous except at each integer. So, yung graph na nakita natin kanina, yung ganon-ganon. And then, but the Whole function, h of x, so we have already encountered Whole function last time. So 2 if x is a rational number and 1 if x is an irrational number is discontinuous everywhere. Yan. So discontinuous itong si Whole, always, everywhere, discontinuous siya.